Dear colleagues, allow me to present this work on moisture as assessment criterion for coal ring and coal layers hazardous characteristics manifestation conducted at the Volodymyr East Ukrainian National University. The agenda is as follows: introduction, methodology, then we shall discuss the results and move on to conclusions. Let's start with the introduction. The relevance of this study is in the unresolved issues regarding safe coal seam mining. The objective is to establish the correlation between the hazardous properties of coal seams and the content of coal of various stages of metamorphism. The subject is coal carbonization in the process of metamorphism on the example of the Donets coal basin. Moisture is one of the most important quality indicators of coal. The significant content of moisture has an adverse effect to heating performance and processing characteristics of coal. It reduces its caloric value and thermal resistance. Its grading, screening, and dressing becomes more difficult. It increases its carbonizing time and other coal processes and makes its transportation as ballast more expensive. To determine the above properties, the total coal moisture content dried out to the constant weight at 105-110 degrees Celsius shall be found. Presence of different forms of moisture in fossil coals essentially influences the coal layer's hazardous characteristics manifestation during mining. The significant role of moisture has been found in the gas dynamic events and endogenous fires occurrence, presence of dust forming capability, and explosive properties of the coal dust. These and several other negative manifestations of the coal layers hazardous characteristics and connected with changing the composition and properties of coals during their metamorphic conversions. Um, Generically, metamorphism implies various geological processes which influence change in the structure, mineral, and chemical composition of coals. Different forms of moisture content in coals are connected with the metamorphic conversions as well. Um, Determination of moisture content of each form and assessment of its influence on the coal layers tendency to manifest their hazardous properties is related to the mining problems, which have not been solved yet. Due to this, research of moisture as an indicator of the coal metamorphic conversions is important today. The regulatory environment improvement largely depends on the results. It will help to reduce accidents and risks of injuries in coal mines. Carbonization is one of the components of fossil coal metamorphic conversion processes. It consists of the carbon content increasing and hydrogen and oxygen reducing in the organic matter. In addition to carbon, hydrogen, and oxygen, variation of the nitrogen and sulphur content takes place in the organic matter during metamorphic processes. As a rule, the total content of carbon, hydrogen, oxygen, nitrogen, and sulfur is at least 99% of the whole organic matter. For this reason, the carbonization indicator value in all the coal rings shall be determined by this ratio. The work procedure is actually based on the functional dependence of the totality of considered organic matter components on the carbon content. This provision is confirmed by the experimental data concerning variation of the components hydrogen, oxygen, nitrogen, and sulfur totality depending on in organic matter. The information concerning variation of the components hydrogen, oxygen, nitrogen, and sulfur totality depending on carbon content is shown in Table 1. There's also data on moisture in the coal samples which correspond to the total moisture at the considered coal ring. Dependence diagram of moisture on carbon changes ambiguously. Um, When increasing the carbon content up to 86.5%, the moisture content in coal samples is reduced rather majorly by non-linear dependence from 7.34 down to 1.59%. Carbon content increase of 80 to 86.5% reduces the moisture content less intensively in linear fashion from 1.59 down to 0.78%. Then in the carbon variation range of 86.5 to 91.5%, the moisture content growth starts from 0.78 up to 3.32%. Such a variation of bed moisture is confirmed by the statistics. Curve 4 of the average data is within limits between curves 1 and 2 of potential individual variation of moisture values for coal of different basins. It proves that initial data reliability, which has been received from the average results of analysis of more than 1,000 samples of the Donets Basin coals. Organic matter conversions under elevated temperatures and pressures are complex by nature. The majority of organic matter components are intercorrelated between themselves. They include moisture content as well. The moisture indicator depends on the carbon content, and its nonlinear link with the oxygen content is established as well. It evidences that in the first factor block, which determines the coal ignitionability as minimum, it is necessary to consider the elemental relations between carbon, hydrogen, nitrogen, sulphur, and oxygen. Based on its quantitative variation tendency, the carbon is a key indicator of the metamorphic process's intensity. The other components supplement their characteristics. The most intensive variation takes place in the oxygen and moisture elemental content. Rank order of the components based on their part in carbonization in different metamorphic stages influences the chemical activity of coal, including their liability to spontaneous ignition. The most ignible coals are those which have the leading places of oxygen, moisture, and sulfur in the rank order by the carbonization indicator. Using the initial data in table 1 on relation of the carbon variation and total of the of other components of organic matter by equation 1, the carbonation indicator numerical value have been determined in the different coal ranks. In conclusion, the conducted research allows us to make the conclusions important for the legal environment improvement. The different forms of moisture in fossil coal significantly determine the coal layer's hazardous properties, because dynamic events, liability to spontaneous ignition, and dust forming capability, coal dust explosibility. Metamorphic conversion intensity during establishing the coal layer's hazardous characteristics shall be determined by the useful quality indicators, which cannot directly characterize change in the elemental composition and properties of fossil coals. Metamorphic conversions Metamorphic conversions intensity is characterized by increasing the carbon content and decreasing the other components in organic and mineral parts composing the fossil coals. A method to find the bed moisture part in coal carbonization has been developed. The study of the relationship between the general moisture part in carbonization and that of total of other components of the organic matter shows not only the elemental composition conversion but the coal inner structure as well. Content of any form of moisture in the coal shall be considered as the rank index necessary to establish the coal layer's hazardous characteristics. Ladies and gentlemen, thank you very much for your attention.